All right, let's do our last section for the night, and that is like terms. Now, I'm pretty sure that this is a review topic as well, but just in case, I'm going to slow this one down a little bit, and this video will be a little bit longer. We have 4 vocabulary words that we're going to focus on. We're going to focus on the word term, we're going to focus on coefficient, like terms, and constants or constant terms. When we use that word term, we're talking about a number, variable, or product or quotient of numbers and variables. So we could be talking about something as basic as 3x. We might be talking about something as complicated as 4x squared y, or it could be even more complicated. We might even be talking about 1/2 x to the third yz. As complicated or as uncomplicated as the case may be. Each of these represents an individual term. In our terms, we have different parts. We have the variable portion, and we have the coefficient. The coefficient is the number in front. So in my first example, the coefficient is 3. In my second example, my coefficient is 4. And in my third example, my coefficient is 1/2. Just the number in front of all the variables. Now this third term is the one we're really focused on in this section. We're focused on like terms. They are terms which have the same variables raised to the same powers. Coefficients are usually differing. So that when we look at like terms, we're going to be looking at things like 3x and 7x. Or maybe we're looking at a set like 1/2 xy and -17xy. Notice that the variable parts of each pair are the same, and the coefficient part is different. The last piece we need to talk about in terms of vocabulary are constants or constant terms. Those are terms that do not have a variable. So all of my examples had variables in them, but I could just as easily have used a constant like 7, -6, 2/3, because those numbers do not have variables. They would be considered constants. I want to go back and I want to add them to my terms list because in our notes, I don't want you to think that they weren't terms to begin with. So I added them to my list. This section actually is relatively easy. Oops, let's erase that. And it's relatively easy to see how to do these problems. The first is that we have to identify the terms, then tell which ones are alike, what are the coefficients, and what are the constant terms in each expression. So in question number 1, we have 4 separate terms. They are 3x, -4, -6x, and 2. I want you to see right away that I listed that as -4 and -6x because when we identify terms, we're always doing it from a sum, or the problem should really be written with all addition problems, or all addition signs. So if it's not, if it's a subtraction, then you could treat that term as a negative term. Now we need to list our like terms. We have 2 pairs in this problem. We have the first pair, let's change colors because I didn't leave myself much space here. The first pair of 3x and -6x. And the second pair of -4 and +2. My coefficients, remember those are things that have variables, right? So the number in front of the first variable is 3. The number in front of the other is -6. -4 and 2 are not coefficients, they're constants. So they get listed down below. -4 and 2 are constants. Would you please attempt problem number 2? Once you have it finished, come back and check your work and see how you did. So check number 2. Okay, so you should be back, and our terms, again, we have 4 terms in this problem: negative 7y, 8, negative 6y, and negative 13. The ones that are alike are negative 7y and negative 6y, and then 8 and negative 13. Coefficients, numbers in front of variables, negative 7 and negative 6. And constants, numbers without variables, 8 and negative 13. The second piece to like terms is right here in a very, very, very important phrase. It's kind of odd that my highlighter is orange. In algebra, only like terms may be combined by addition or subtraction. Notice that those 2 important words, addition and subtraction, those are huge in this section. You can only add or subtract if you have like terms. It doesn't say anything about multiplying and dividing because that has different rules. But with addition, they have to be the same. So let's go ahead and look at a couple of examples. So this first problem, number 3, has 2 terms, 7b and 3b. They are alike, so I can add them. Positive 7 plus positive 3 would give me 10b altogether. 10b. We'll go to number 4. Pause it and give it a try. Pause it. Okay, hopefully you're back and you've done this problem. And hopefully the first thing you saw was that this should really be a 1x. And you didn't have to write that 1 in, but your eyes should have seen it even though it's not there. 4x plus 1x is 5x. No other terms to worry about, so we can finish. Now question number 5 is a bit of a trick question because it wants you to see that both terms have the variable a, but you need to notice that their exponents are different, which means that these are not like terms. They do not have the exact same variable part, so that this problem is as simplified as it gets. There are no like terms to be combined. So we just simply need to write 10a squared plus 3a to the third. There's nothing else that we can do with that. Alright, the next row is just a little bit more difficult, although this concept stays exactly the same. We go ahead and we go in alphabetical order or from the largest power of x to the greatest power of x. I like to use these underlines to identify which ones are my like terms. So 21c and positive 8c are alike, and 31b and negative 3b are alike. So 21c, alphabetical order, Mrs. Sturgeon, positive 31 plus a negative 3b gives me, 28, correct? That gives me a positive 28b. And then we can do our c's. Positive 21 and positive 8 give me 29c plus 29c. Remember, like terms are the only kind that can be added or subtracted. In this case, b and c are not alike. They cannot be added. Alright, I'm going to work through 7 and 8 with you, and I'm going to leave 9, 10, and 11 for you to try on your own. But if you're feeling confident, now would be a good time to pause, give them a try, and then come back and listen to explanations. So we have like terms, 3x squared and positive 2x squared. Notice that I include those signs in front when I'm underlining, because I like to do these problems by always adding. So positive 3x squared, positive 2x squared gives me 5x squared. Then I go to my x's, because that's what this 5x is. It's a positive 5x, and because of that subtraction, that makes that a negative 7x. They are alike. That's why I dotted them underneath both of them. So positive 5x plus a negative 7x gives me negative 2x. I don't have any more terms to consider. So my final answer, because x squared and x are not like terms, my final answer is right what we see, 5x squared minus 2x. All right, we're getting into a more complicated. Look at all these powers and letters. It's kind of crazy. Let's take a look. I've got a positive 3AB. It's not an AB, not an AB, not an AB. Oh, there we go. There's an AB. And it's a 1. Whether I put that 1 in there or I just see it with my eyes, doesn't matter. So I've got 4AB. Let's go to the next one. The next term is 4a squared b. 10a squared b, and that's a positive. 10a squared b. That's not a squared b, so it's not a like term. It cannot get added in this group. Positive 4, positive 10 are my coefficients. So I end up with positive 14a squared b. And this last term doesn't have anything that's alike, nothing to combine with, so it just needs to be included in my answer. Negative 6ab squared. This type of problem where there's a tag along at the end is the type that most students have problems with. So if you're struggling with that in class when we have our practice time, make sure that you ask me about it, because it's not a hard concept, but sometimes you need to hear it just for yourself in order for it to make sense. I told you when I started this row that I wanted you to do 9, 10, and 11 all on your own without my help. So now would be a great time for you to pause the video, try problems 9, 10, and 11, then come back and check your work. Okay, hopefully you're back and now you're ready to check over your work. How did you do? Your like terms? Did you end up with 2 terms in number 9, 3 terms in number 10, and only 1 term in number 11? If you didn't, then maybe you should make some time and make sure that you're practicing in class on this like terms portion, because it's probably the hardest one. I want to point out this last piece, this common mistake that students make. And remember that 1x plus 1x equals 2x, but x times x is what gives us x squared. So what this is really reminding you is that when you're adding, you do not change the exponent on x. That gets changed when we multiply. When we add, do not change the exponent on x. That occurs when we multiply. I will see you in your next video.